This time we're going to do exercise 3B, sorry, question 3B. Um, this is a really tricky one actually, because you're being asked to prove that this improper integral doesn't exist. So let's have a go at doing it. We start exactly the same way, but then you're going to see that we end up with problems. So I want you to think about how you would rewrite this as a power. I'll give you a second to think about that while I just write out the next line. Right. The way that we can rewrite this is x times x to the power of a half, right? This is to the power of a half, the x root x. Then you can think about the first one as a 1. When we multiply, we just add the powers together. So we get 3 halves, but it should have been on the bottom of a fraction. So it needs to be negative. And we're doing this with respect to x. All right, let's do our integration. So we add 1 to the power and we divide by the new power. Now, we don't divide by fractions, do we? We multiply by the reciprocal instead. So let's do that. So we end up with negative 8x to the power of negative half. And then we've obviously got a negative power, so it's negative 8 over root x. That is our integral. Now let's start putting our things in and you'll see that it doesn't work. So if we go up here, I've got negative 8 over root m. And then I'm going to subtract negative 8 over root 0. You can see that this is impossible. So the problem is we've only got one piece of information. So what we need to do is check what happens as it tends towards infinity and what happens as it tends towards negative infinity, because we don't have any information to compare it to on one of the sides. So if we just start putting in some values, again, if you can think about what happens with m, that's fantastic. But let's just do a little bit of testing. All right, so I'm going to change color. So let's tend towards infinity. So as I have negative 8 to the power of 1, that's going to be negative 8. If I had negative 8 to the power of, why am I saying to the power over root 1? Over root, not 2. Let's make it something that's actually square rootable. Root 4. I'm going to get negative 4. If I have negative 8 over root 100, that's going to be negative 8 tenths. So you can see here, I am tending towards 0. So as we move towards infinity, we tend towards 0. So that is one answer. All right, I'm going to get rid of these so I can do the other version. So what happens if I tend towards negative infinity? So what happens if I make my numbers smaller and smaller? Let's change colors. So I can have negative 8 over root. Let's make them fractions now. So if I have negative 8, what do we want to do? Let's just make a fraction to the power of, sorry, root 1/8. If you type that into a calculator, you'll get negative 16 root 2. What happens if I do negative 8 over the square root of 1/100th? If you type that into a calculator, you get negative 80. So what you can see here is I'm not getting smaller this time, I'm getting bigger. And I'm not going to be approaching anything. I'm just getting smaller and I'm getting bigger and bigger and bigger all the time. So that means I am approaching infinity. As m approaches negative infinity, the value of this approaches infinity. Or sorry, negative infinity, doesn't it? Which means there is no number which this integral is going to be approaching. Therefore, it is impossible. It doesn't exist. There is no value that it is going to be contained by. And again, if you want a little picture, if you can remember the shapes of these graphs from last year, it looks something like this. So you can see in this direction, it tends towards 0. Terrible drawing. In this direction, it tends towards infinity, which is why we can't really give it a value. All right, I hope that helps. I know that question 3 is going to be a bit tricky, but do let me know if you need any extra help. Good luck.